Alrighty, lesson 6, last one in the unit here. I want to show you how cross multiplication is the same as clearing fractions. So for rational expressions that are proportions, try cross multiplication. With equations, you can eliminate their fractions by clearing them with their LCD as we have been, but it would be quicker to solve the equations in this lesson using cross multiplication, okay? Cross multiplication is a way to sort of clear a fraction, so I wanted to show you, for example, this one right here. If you were going to clear the fractions the way we have been doing, this would be 7x because that's my LCD, and you multiply both terms by your LCD, okay? And it would be 7x times 4 over x, and the x's would go away, right? So you'd be left with 28 here, and then 7x times 2 over 7, you reduce the 7, so you get 2x over there. Dissolve by 2, you get x equals 14. Okay, so that's how you would do clearing fractions. You have to find the LCD, then reduce, and then you're there. And you can do that for this section as well. I just want to show you one other thing. To do instead, okay? Cross multiplication, you would actually multiply the 7 times the 4 and get your 28, and then there's your 2x. And that's what we spent a couple of minutes trying to do with our LCD. It's just faster that way, and less steps, okay? So when you have something that's, you don't really want to spend the time finding the LCD between those two numbers. It would just take a long time. So this is a good chance for you to use cross multiplication just for these cases, okay? Just for these cases. What is 3 times 2? 67. I believe I have that written down. Let's see. That is 801. Isolate my variable by dividing by same. 801 divided by 89 is apparently 9. Okay? So you can check that by, if V is 9, that means I divide by 3 to get 3. And if I divide by 3, I should get my 89. Okay? Just to check. So that's just another way to process these as you're working on them. All right. Lesson 6, we're supposed to be able to solve variation problems by creating variation equations and finding the variation constant. All right, we're using the variation word over and over again. The important part is the variation constant, which is represented by the letter K. Okay, variation of constant, or K. Skill 1, create and solve formulas for the constant of the variation. It is best to set up the formula using two variables that equal K. Okay? That's the first step of every problem in this lesson. Find K. All right? Once you find K, you can use it to do other things. So step 1 for us is going to learn how to find K. I think people run into trouble when they don't keep that in mind. They want to go right to the problem where it gets the part of the answer, but to do it consistently correctly, you really need to find K first, okay? So there are two types of relationships between these two variables, direct and inverse. we're talking about relationships. So the direct relationship is when two different events or units must increase or decrease at the same time. As one goes up, the other must go proportionally up as well. Think of these two events as a fraction or ratio together. So if their relationship is 5 to 8 or 5/8 as a fraction, as the numerator increases, so does the denominator. You're making equivalent fractions, so to speak. Okay? So if you have 5 and 8, you increase the numerator, or the 5, to 30. Okay? So if you've got 5/8, and this is 30, what does x have to be if this is down here? Well, apparently it has to be 48 to make equivalent fractions. This times 6 or this times 6 will be that. Okay? The numerator has to increase the same amount proportionally to the denominator increase. Okay? And that's going to equal k. Whatever 30 divided by 48 is the same thing. Here, look over here. 5 divided by 8 is 0.625, which is exactly the same as 30 divided by 48. And this right here, this 0.625, that's k. That's the constant variation. Okay? So let's look at one of these problems. If the price of an item varies directly with the sales tax. So what are the two things we're talking about? We're talking about price and we're talking about sales tax. These apparently vary directly, right? So step 1, identify the two variables, price and tax. Variables, as in the price, I'm going to give it a P. You get to decide unless the problem tells you. And tax is a T. Okay, those are the two variables. And then it says that they vary directly. So you always put the two variables with a constant every single problem. Okay? If it varies directly, that means it's a fraction. Okay? It's a division. The saying is varies direct means divide. Okay, that's some way some people remember it. D with D, okay? This is going to be divide, this is going to be multiply. So people remember the D to D one. So before we even touch any numbers, we take the variables we've determined, put them divided by itself. The first one always goes on top as the numerator, the second one's the denominator, and the K is, you can make it to the left or to the right, but that's what that equals, all right? And then they're going to give you two pieces of information. $25 item, that's a price, right? Has a tax of $2. If you take 25 and divide it by 2, you get the constant of variation, or K, for 12.5. That's it. So a couple of questions are just going to ask you for the constant of variation. That's what that is. So most of the problems are going to go on to ask you some more information about that, but we'll cover that in just a second. Okay. So for practice, let's see. We have kilograms of I'm so sorry. Number of kilograms of water in a human body varies directly as the mass of the body. So however you want to do this, this is number of kilograms of water and mass, because it turns out both of them are referred to in kilograms, so you want to be careful which one's which. You can actually go here and say this is a person and this is water, so no matter what, I'm going to go with W with the water. Then you can either go mass with an M or person with a P, but that's up to you. The water varies directly with the mass, so I usually stick to that sentence. That's K, okay? And then they tell me the water, that needs to go on top once I've organized that. And then 696 is the person or the mass on the bottom. And apparently that reduces to 2/3. Okay, so K equals 2/3. For the indirect, remember there's two relationships, direct and indirect. This really should be inverse. I will fix that. The inverse relationship, which is a better word term, is when two different events must increase or decrease opposite from each other. So as one goes up, the other goes down proportionally. Think of these two events on a balance together. On one side is K, and both of them together as a product on the other side. Okay? So if you have W and P, they're going to be multiplied together. So this is the balance. This is going to be on one side, and this is on the other side. So as this one goes up, that one goes down, because the weight has to be the same. Okay? So for example, if you have 5 times 8 is 40, as 5 increases to 10, that means the 8 must decrease proportionally the other way to keep your K, your constant. Okay? So an inverse relationship. For example, time required to drive a fixed distance varies inversely with the speed. The distance, so the time required. So if you want to put D for distance, that's up to you, but the problem is that it's going to get a little confusing because this is kilometers per hour. So either one would work, time or distance. Right here, it takes 4 hours at a speed of, so here, let's go back. I just demonstrated how confusing this can be. Hang on. All right, I'm going to do it more slowly. The time required to drive is a fixed, the time required to drive a fixed distance varies inversely. So its time varies inversely as speed. That's better. Because then it goes on to talk about hours and kilometers per hour. So time, speed, varies inversely means they're multiplied together. Okay, substitute the numbers in, time and speed, and you get a K of 400. Okay, let's try another one. The intensity of light measured in foot candles varies inversely with the square of the distance. I am going to have to fix that one. No, square of the distance. Okay, sorry. I'm going to start another video in just a second. Let me finish this one. The intensity of the light measured in foot candles varies inversely with the square of the distance from the light source. The intensity of the light, distance, the intensity is in foot candles, distance of 6 meters. Okay, varies inversely means I'm multiplying together to get K. So let's go intense distance equals K. So intense, wait, that's too many. Sorry. I got interrupted and I can't get back to it here. 6 equals K. And let me check my key or get my calculator out for this one. All right, let's double check because I'm messing up here. Intensity of the light measured in foot candles. Intensity is an I. Varies inversely, which means we're multiplying. The square of the distance from the light source. So here's the intensity times the square of the distance. So orders of operation say square first, and then multiply. So K equals 1.98. Okay. I will make another video for the rest.